Okay, so this is 2016, so it's question 9. So it says data on earnings were published for a particular country. The data showed that the annual income of people in full-time employment was normally distributed with mean of 39,400 and a standard deviation of 12,920. So it says the government intends to impose a new tax on incomes over 60,000. Find the percentage of full-time workers who will be liable for this tax correct to one decimal place. So I need to see whereabouts that 60,000 falls on my curve. So I get my Z score because I'm comparing it, so I'm standardising it. So it's 60,000. Take away my mean. I was given that as 39,400. All over my standard deviation, which is 12,920. When I calculate that, I get Z is equal to 1.59. Okay, and I go to my log tables and I get that is actually equal to 0.9441. So basically I'm finding out this score here, that's telling me all the people that are below 60,000, but I want to find the people that earn over 60,000, so I need to find the other end of the scale. So basically if I was to draw it out like this, okay, so my mean would be here, and I have roughly, I'd say about 94% of the people here, so I'm after shading in, that's what I know at the moment, okay, so 94% of the population earn under 60,000, but I want to find it above, so I go 1 minus my standard deviation score, and I get 0.559, which is 5.59%, and then to one decimal place it's 5.6%. The next part of this question, it says the government will also provide a subsidy to the lowest 10% of income earners. Find the level of income at which the government will stop paying subsidy correct to the nearest euro. Okay, right. So if I was to even look at my log tables, well, first of all, what I need to know, okay, so 90% are going to be above it, okay, right, so if I know that 10% represents the lower end, 90% are going to be above that, okay, so I'm getting all above it, so I get my Z1, when I get 90%, is equal to 0.9, when I get it in my log tables, I get 1.28, okay, so I know what my answer should be equal to, and because I'm dealing with, I'm going the opposite way. I want to get the negative value of that, minus 1.28. I'm looking for, okay, what value are they going to stop paying? So I'm looking for what is my actual X value. So it's X, take away my mean, all over my standard deviation again, and I get the value that they're going to stop paying. So I get X minus 39,400. I multiply this up, and I get then X on its own is going to be 22,862.40, and then to the nearest euro is just 22,862 euro. That's when they're going to stop paying that rate. The next one, what we have here is sometimes later a research institute surveyed a sample of 1,000 full-time workers. Okay, so that's my sample size, 1,000. And found that the mean annual income of the sample was 38,280. Test hypothesis at 5% level of significance that the mean annual income of full-time workers has changed since the national data was published. Okay, state the null hypothesis and the alternative and give a conclusion to this question, right? So my null hypothesis is basically that the mean is 39,400. This is where we had above up here. That was my actual mean. And then what I'm trying to say, because they're saying it's changed, we're going to say that the mean is 39,400. Okay, right, so I need to get my Z score using this mean here, okay, to standardise whereabouts that does fall in my 5% significant level. So I get Z is equal to 38,280 minus my mean, which is 39,400, all over my standard deviation over my root n, because I'm dealing with a sample size. Okay, and I get minus 2.74.